Hello everyone, and welcome to our session on rotating arrays. Today, we'll explore how to shift the elements of an array by a given number of positions, a common problem in data manipulation and algorithm design. Here's what we'll cover today. An introduction to array rotation. A clear problem definition along with use cases. Various approaches to rotating arrays. A detailed explanation of the reverse method for in-place rotation. A complexity analysis and discussion of edge cases. Code examples and visual demonstrations. Finally, we'll wrap up with a Q&A session. This roadmap will guide our discussion through each important aspect of array rotation. To begin, what does it mean to rotate an array? Rotating an array involves shifting its elements by a specific number of positions. This operation is useful in several applications such as data manipulation in computer graphics, implementing circular buffers, and scheduling algorithms. When considering rotation, we need to decide on the direction, left or right, the number of steps to rotate, and whether the operation should be done in place or using extra space. Let's define our problem. Our objective is to rotate an array by k positions. For a right rotation, the last k elements move to the beginning. For a left rotation, the first k elements move to the end. For example, given the array 1, 2, 3, 4, 5, and a right rotation by 2, the result would be 4, 5, 1, 2, 3. This basic example sets the stage for the different methods we'll discuss. There are several methods to rotate arrays. Using an extra array. This method involves copying elements into a new array in the rotated order. It's simple to implement but requires additional space. In-place rotation using reversal. A popular method that involves reversing parts of the array to achieve the desired rotation. For a right rotation, the steps are: reverse the entire array. Reverse the first k elements. Reverse the remaining nk elements. This approach doesn't require extra space. Other methods. These include cyclic replacements or shifting elements one by one using temporary variables. Each method has its trade-offs, and we'll dive deeper into the reversal approach next. Let's go through the reverse method step by step. Reverse the entire array. Reverse the first k elements. Reverse the remaining nk elements. For example, consider a right rotation by 2 on the array 1, 2, 3, 4, 5. First, reverse the entire array to get this. Then, reverse the first 2 elements to get 4, 5, 3, 2, 1. Finally, reverse the last 3 elements to arrive at 4, 5, 1, 2, 3. A visual demonstration on this slide will walk you through each of these reversal steps with a step-by-step diagram. On this slide, we have a visual demonstration of the reversal process. You'll see the array before and after each reversal operation. Arrows will indicate the direction of rotation and highlight the segments that are being reversed. This visual aid makes it easier to understand how the reverse method transforms the array step by step. To see this in action, let's write the code. And to write the code, let's proceed to Visual Studio Code. I am into the Visual Studio Code. Now I am first going to create a function called reverseArray. In this function, I am taking an array along with 2 indices, start and end, that represent the segment of the array I want to reverse. I then use a while loop to swap the elements at these positions, moving inward until the segment is fully reversed. This function is essential because it allows me to reverse parts of the array, which is a key step in the rotation process. Next, I am creating a function called rotateArray. In this function, I want to rotate the entire array to the left by d positions. To ensure that the rotation amount does not exceed the array's length, I first calculate d%n, where n is the size of the array. Then, I use the reverse technique. First, I reverse the first d elements. Then, I reverse the remaining n d elements. Finally, I reverse the whole array. This sequence of reversals effectively rotates the array to the left by d positions. After that, I create a helper function called printArray. In this function, I loop through the array and print each element with a space in between. This function is used to display the contents of the array so I can see the result before and after the rotation. In the main function, I define an array containing the elements 1, 2, 3, 4, 5, 6, 7. I calculate the number of elements in the array using the size of operator. I also set the rotation value d to 3, which means I want to rotate the array to the left by 3 positions. I then print the original array by calling printArray. Next, I call rotateArray to perform the left rotation. Finally, I print the rotated array to observe the changes. This complete program demonstrates how to rotate an array efficiently using a sequence of reversals, providing a clear example of the rotating array concept in C++. Let's run it and you will find the output with rotated array. Now let's proceed to the presentation. Let's analyze the complexity and consider some edge cases. Time complexity. The reverse method operates in O, N, time, as each element is swapped at most once during each reversal. Space complexity. It uses O, 1, extra space since it performs the rotation in place. Edge cases. When k equals 0, no rotation is needed. When k equals the array's length or a multiple thereof, the array remains unchanged. Negative k values can be normalized or interpreted as left rotations. Understanding these factors is critical to ensure your implementation is robust and efficient. To summarize, rotating arrays is a common problem that can be solved using various methods. The reverse method offers an efficient, in-place solution with a time complexity of O, N, and space complexity of O, 1. It's important to understand the problem requirements, such as rotation direction and the number of steps, as well as to consider edge cases. Visual demonstrations and code examples help solidify these concepts. On this note, I am stopping over here. See you in the next session. If you have any question, drop me the question at comment section. Thanks for watching. See you in the next session.